Hello academic stars in the house, welcome to Caltex Academy. Today on our board, we're looking on how to write chemical formula from their chemical names. So if you're excited, come closer and let's dive into the video. So we can see on our board here that we have one question with 4 subsections. So it says, write the chemical formula for each of the following chemical names. So we're given chemical names and we have to transform them into their corresponding compounds, the elements that form that name or that compound generally. So this technique is very important because in your chemistry examination, you can be given this kind of questions in maybe volumetric analysis. So you have to transform them into their compounds and you write equations, balance them before you use it to maybe do calculation or to get a molar ratio, any of those. So we need to get this technique right from this video. Now, the first thing we have to do is to copy down what we are answering, and part A, we are given that we are transforming this formula of the compound with the name of sodium carbonate. From what it sounds here, you realize that there are two things that are involved here. We have radical and we also have this metal here called sodium. When radicals and metals come together, they always form salt. So we can go ahead and transform the first one here. We know how to write the chemical symbol of sodium as Na. And since it is one of the elements in group 1, then it has lost one electron, so we can give here positive. And the next one here, we need to write the carbonate, and carbonate is a combination of two elements, that is carbon and oxygen, forming radical. And it has the oxidation state of 2 negative. Now from here, in order for us to get this compound correctly, what we have to do, we have to make interchange. So the interchange is of this number here. So we can just get only the number and we take it down here as a subscript and we place it here as 2. Now we can also see here that this one is positive, meaning there is always 1, and in chemistry we write the number before the sign. So here we have our silent 1 here. We need to bring it somewhere here and we place it there as 1. So what we have to do, since our carbonate here is having 2 elements, this one caters for all these 2 elements. So let us get more space and see how we can write this. So we have there sodium with our 2 that has come down here, and this radicals is having 2 of these elements of carbon and oxygen. So we have here 3. Now we realize that we had 1 somewhere here, and since 1, if you multiply with these 3 atoms of oxygen, will remain the same, then we simply ignore our 1. And what brought these two things together? We had this positive and negative coming together, just like north pole and south pole of a magnet will attract. So the positive ions and the negative ions will attract together, bringing these 2 different elements or this radical together with the metal of sodium together to form one compound. So finally, we can simply write our answer as sodium with our 2 down here, and we place in our carbonate next to it like that with our 3 here. So the name here is sodium carbonate. Now let's look at also number 2. that is part B, and that is iron 3 sulfate. Now we also know that iron consists of two states. At most, we have iron 2 and iron 3. Iron 3 is brown and iron 2 is greenish or pale blue. So we can see that the first one, iron 3, can be written like this with 3, and since it is gotten from group 3, it has lost 3 electrons in its outermost shell. So that is why we're given here 3 positive. Now let's match it with the next one here, and that is sulfate. What we have here, it gains 2 electrons and we have minus 2. So what we do is also the same thing. Our 3 from here will have to cross down here, and we have the 3, and then our 2 up here from sulfate will come here and cross down here, and we have 2. Now positive and negative will combine them together and we get a compound that looks like here. Let's get more space. So we shall get a compound with F, E, with our 2 down here, and then the sulfate also has come and has closed that gap with oxygen attached to it. But now, since 3 is more than 1, if it multiplies the number of atoms of each of these elements of sulfur and oxygen, it will increase them. And for that case, we need to create a bracket here. And also we have this bracket closed, and we place our 3 here. So for that case, that becomes our formula. And at least, maybe let's write it in just one color. And we have Fe with our 2, and we open up this bracket and we write our sulfate. When we close that bracket, and we also place our 3, such that the number of atoms of oxygen would be 12 if you open up this bracket, and then the number of atoms of sulfur would be 3. So this becomes our iron 3 sulfate. Now let's look at the third example here, that is potassium iodide. Now from there we can see that 2 elements. One is potassium, and potassium is having a chemical symbol of capital K. Is also in group 1, so we have here plus, and iodide comes from iodine. Iodine is an element from group 7. They are the halogens, salt-making elements. So if these two combine together, since they are 1 to 1, we'll just have an interchange of 1 here, and also bring it here 1, and positive and negative, we'll just pull them together to produce our potassium iodide like that. So that becomes our chemical compound of this chemical called potassium iodide. Now let us move on to our last part of this question. Let's scroll up to see how it looks like, and that is copper 2 sulfate dehydrate. So let's copy it down here and see how we can derive this formula of part D that says copper 2 sulfate decahydrate. So the name is long, but you can cut them into syllables. So the first syllable here, according to chemistry, would be copper. The next one is sulfate. The next one is deca, and then hydrate. So from here, you already know sulfate and you know copper to be the element in group 2. So we can recopy it outside here. And we have, if this is copper, Cu with 2 plus, and we have sulfate here, So with that 2 negative. Now let's first write this part. And since we have here positive 2, negative 2, they will simply come together, and the nomenclature here is always represented by a dot because this is water of hydration. So we have always representing it with the N, and hydrates there comes from water, so we place there water. Now we shall replace this N with deca, and the counting here is mono is 1, di, and we continue, deca is 10. So this interchange will also take place. Here we have that, and we have here, in fact, 1, 1, because these two will just neutralize. And finally, you realize that we have copper 2 sulfate is having this formula like that, then dot our number of water here, that is deca, meaning 10. So maybe let me use a different color to represent that number 10, as this is hydrated salt with our water of crystallization to be 10 water. So this is a compound which is in crystalline form, and it is not dry. This water will vary. We have hexa, hepta, nona, deca. It depends. So you can select it to use in the laboratory depending on the need. So this is the compound for this name, and that is copper 2 sulfate decahydrate. I hope you enjoyed this video. So if you do, give it a like, and then subscribe to the channel, share with friends, and see you in the next video. Peace out.